Piston rings are small, circular metal bands fitted into grooves around the outer surface of a piston. They form a tight seal between the piston and the cylinder wall, and they perform three essential functions in an internal combustion engine. First, they seal the combustion chamber, preventing the high-pressure gases from leaking past the piston during the power stroke. Second, they regulate oil control by scraping excess engine oil from the cylinder walls and returning it to the oil pan, preventing oil from entering the combustion chamber and burning. Third, they help transfer heat from the piston to the cylinder wall, which helps in cooling the piston during operation. There are two types of piston rings: the compression ring and the oil control ring. About 2 to 4 compression rings are fitted to the piston, while 1 to 2 oil control rings are fitted to the piston. The piston pin, also called the gudgeon pin or wrist pin, is a hardened steel shaft that connects the piston to the connecting rod. It passes through a hole in the piston, called the piston boss, and through the small end of the connecting rod, allowing the piston to pivot smoothly as it moves up and down during the engine cycle. The piston pin must be strong and heat-resistant because it endures constant stress and high temperatures during the combustion process. There are 3 main types of piston pins: the set-screw piston pin, which is fastened to the piston by a set screw; semi-floating piston pin, which is fastened to the connecting rod by a clamp screw; fully floating piston pin, the pin floats in both piston boxes and the small end of the connecting rod. It is prevented from coming in contact with the cylinder wall by 2 circlips. The crankshaft is a major rotating component of an internal combustion engine that converts the reciprocating motion of the pistons into rotational motion that powers the vehicle's drivetrain. It sits at the bottom of the engine block, supported by main bearings. It's made from forged steel or cast iron. The crankshaft must handle extreme forces, heat, and high-speed rotation without failure, and is connected to each piston via connecting rods. As each piston is pushed down by combustion, the connecting rod turns the crankshaft, creating continuous rotation. The crankshaft has crank pins, journals, for each connecting rod, counterweights to balance the forces of moving parts, and oil passages to keep it lubricated. At one end of the crankshaft, a flywheel or flex plate is attached to help smooth out power delivery and maintain engine momentum. At the other end, it has a crank pulley to drive belts for accessories like the alternator or water pump, and a gear that drives the camshaft.